All right, everybody, let's talk about more solving for unknown angles. This time we're going to use something called a transversal. This first one doesn't really have transversals, so we're going to do it the good old-fashioned way. It's kind of a nice little way to review on the previous stuff. Now, I know it can seem really rough, but it's not that bad. I know what you guys are tempted to do. Y'all are tempted to say that this is a 90-degree angle, even though that's not given technically. And you're likely to say, all right, well, that means that I'm just going to do the complementary angle. And then say, all right, I'm going to add up these angles right there and have them equal 90. Now, that will work in this case, for sure. And it definitely works with our intuition, because we know that if you add these together, you're going to get 180, and then you're going to subtract this 90-degree angle so that this whole thing right here has to equal 90. So that works too. Problem is, they didn't give that to us, and without an extra step, a step of proving that this whole thing is 90 degrees, we can't just jump from the get-go and just do that. With this math stuff, with the more like proving things and explaining our reasoning, we need to make sure that we don't skip anything. Imagine you're in a conversation with someone or an argument, and you just kind of skip over one part, and then they don't understand where you got that information, and that kind of thing can start arguments or inflame arguments. But in our case, it's not going to change anything. We can just use supplementary angles from the information that they gave us. So supplementary angles add up to be 180, and we could just do this whole thing, and it's going to end up being the exact same thing, and it will work without having to go and prove something again and then do extra work. So this angle right here is 90 degrees. It's given with the little square symbol that says that it's a rectangle angle type thing, a right angle. Rect, in that case, means right, or it's 90 degrees. So in our case, let's do 90 for this angle right here, plus x plus 8, which is this part of the angle, plus 2x minus 8 for that angle. All of those angles add up to be 180 because they are the sum. They are consecutive angles on a line, so when you sum them, you get 180. So let's simplify a little bit before we start messing with this. 90, let's do 98. Actually, we don't even need to do that. This 8 minus 8 is 0, so we just have 90 on the left side. So 90 plus 8 minus 8 is still just 90. And then we get 1x plus 2 more x's is 3x's. Y'all got to stop writing just 2x right here when there's this 1x right here. You got to be careful, okay? It's very tempting to ignore it because it doesn't have a coefficient. Okay, so let's subtract this 90 from both sides. And we'll get the complementary angle thing, but it's very easy to goof up if you accidentally jump the gun here. And then divide both sides by 3 to get x is equal to 30. Perfect. So let's go put that over here in our little box, a little blank. All right, let's see what other properties we can notice. We have x is equal, you can rewind the video if you need to but I'm going to delete this now. So let's look at this. Let's look to see if we have anything else that would work. Now, there's a lot of ways to go about doing this, and some are more effort than others. So in this case, we don't want to just jump the gun and try to do this because we don't know what this angle is. If we try to do y plus 4x minus 24 plus whatever that angle is, then we're going to have two unknowns. So we have another line right here, though. All of these add up to be 180 degrees. So let's go ahead and do that. Let's do our y for this angle plus 90 degrees for this angle right here, plus x plus 8 from that angle equals 180. Those are all of the consecutive angles on a line, and they sum to be 180 because they're supplementary. That's us using the vocabulary enough that it just sticks in our brain without having to actively memorize, because it doesn't work when we try to do that. So we have y. We don't know what y is, but we do know what x is. It's 30. We just found that. So we get y plus 90 plus 30 is 120, plus 8 is 128. So let's subtract 128 from both sides to get y is equal to, what is that, 52? 52, I believe. 180 minus 128, 10 minus 8 is 2. Pull that off. 7 minus 2 is 5. Pull that off, 0. Yeah. So this right here should be 52. You can confirm your answer by going back through and seeing if they all work. Once you figure out all of the angles, you can actually do the sum of angles at a point and just confirm that way. All right, now here's the thing. Find the measure of angle BOF. So if I'm trying to find the measure of angle BOF right here, I'm going to have something that will help me. So the only straight line right here that I really like, we can either do all of the angles around that point, or we can just do smaller numbers with that. A lot of ways to do it. We can make an auxiliary line right here, sort of. It's not really an auxiliary line, but it's like continuing that line straight down. But then we don't have enough information for that either. So I feel like the best bet is just to add these all together. So you get y for this angle plus 4x minus 24 for this angle plus the measure of BOF. And that's all equal to 180. That's that angle. That's BOF. That's the angle itself, pretty much. It's not exactly drawn well, but most of our stuff hasn't been drawn to scale anyway. Okay, so y was 52. X was 30. The minus 24 has been staying there the whole time. Plus the measure of angle BOF equals 180. So let's simplify a little bit before we start messing with this. 52 plus 120 minus 124 is a sneeze. Excuse me. That wasn't actually a sneeze. I gotcha. Well, the thing I was writing wasn't a sneeze. The sneeze was real. Don't worry. Let's continue writing this. 52 plus 120 is 172. 172 plus 24 is 196. 52 plus 120 is 172. Plus minus 24. Oops. I made that mistake in my other video, and I made the mistake in this video. So 52 plus 120 is 172. Let me show you a little trick if you ever come across this issue where your brain just doesn't want to work. Let's go ahead and subtract off that 172 from both sides. And just kind of leave that right there, because that might actually help us if our brains just aren't with it today. 180 minus 172 is 8. Now let's add 24 to both sides. Messing with smaller numbers is a little bit easier. Sometimes breaking up our operations can make our brains work better. But either way, the measure of BOF is 32, and you can actually just go back in and plug this in and just confirm. So justify your calculation. So we have 32. Justify your calculation. I skipped a problem by mistake. It's the consecutive angles on a straight line. Consecutive angles on a straight line sum to 180 degrees. And we got that from all of these. And we can say that y was 52, x was 30. We plugged them in, we substituted. Name a pair of vertical angles. Let's look at this and find some vertical angles. Well, the only vertical angles my eyes spy are the ones that are made by these two lines. This is an angle made by those two lines intersecting, and this. So these are vertical angles. So you could have gotten y is equal to 2x minus 8. And you could actually graph this, and that if you do y is equal to 2x minus 8, you can actually graph this, and it kind of shows you get an infinite number of solutions. It shows you all the possibilities of those two angles when you do this. It is a constant rate of change amongst both of them. All right, let's look at this one. So the words on this one are kind of hard, but this is what a transversal looks like. It is a line that intersects with two parallel lines. And there's a lot of really cool properties that come from it. We know they're parallel, in case you're confused about the notation, by the fact that we have this symbol right here. If we had multiple sets of parallel lines, we'd have multiple sets of these to say which ones go with which. And we get a bunch of cool little things here. So this thing asks some questions, but I'm going to tell you everything about these. So we want to figure out what corresponding angles mean. But first, let's read this. Given line AB and line CD, do you see why they're called AB and CD? They're labeled by the points. A third line, EF, is called a transversal if it intersects two parallel lines, AB and CD, at a single point. It intersects each one at a single point, but different places. That's important. This language is important because it's a transversal if it intersects AB at a single point and it intersects CD at a single but different point. This is important because you could have a line like this that you call AB and a line like this that you call CD, and another line that intersects them both at the exact same point like that. That is not a transversal. But what's interesting about this is that there is no possibility of drawing a line that intersects these both that has them intersecting at the exact same point. So it's already kind of nice. But for our terminology, we kind of need to make sure that we understand that. But if we want to talk about corresponding angles, I want to show you A and E are corresponding angles. And that's because when the transversal goes through both parallel lines, do you guys understand that these two correspond, or another word for correspond, phrase for correspond, is go with? That these two, do you see visually how these two go with each other? They're analogous. They mimic each other. These are called corresponding angles because they correspond to the exact same locations or similar locations on the parallel lines. So when the transversal cuts through these, it creates two angles, well, more than two, you're going to find out, that correspond with one another. And in a different color, I can say that B and F are corresponding angles. Those are called corresponding angles because they correspond to the same sides, same locations on the transversal, etc. So I'm going to color code each of the corresponding angles for you. These two are corresponding angles. And these two are corresponding angles. So the ones that share a color in the way I've drawn them all have equal measure. So your answer for this one could be any of those. It could be A and D. It could be B and F. It could be G and C. There's a lot of different answers for that. And by that, I mean there's 8 different answers for that. All right, well, let's look at this other one that talks about alternate interior angles are equal in measure. So what we mean by that, don't let the words get super confusing. Break them apart. When we talk about interior angles, we're talking about the angles that are on the inside, the interior, the inside of the parallel lines. These 4 angles right here are the interior angles. Now we need to look at that other part of it, alternate interior angles. So alternate interior angles. So the ones, they alternate their sides of the transversal and which parallel line that they're looking at. So these ones right here, you can also see it usually, but you can't always see it easily. But they're alternate interior angles because they are on alternate sides of the transversal and they are on alternate parallel lines. So it's important to not accidentally think we're talking about that. These can't be the same unless they're both 90 degrees because that's a straight line. So these ones that I've done in purple are alternate interior angles. these are also alternate interior angles. Do you notice how they're on alternate sides of the transversal and they're on alternate parallel lines? And they're both in the interior. They're on the inside of the parallel lines. So those are also alternate interior angles. Now the book doesn't ask this, but we also have something called alternate exterior angles. Do you notice how these are on the outside of the parallel lines? They're on alternate sides of the transversal, which is the line that cuts between them. They're on the alternate sides of the transversal, and they're on alternate parallel line. So same idea for alternate, but in this case, we're looking at the exterior angles. So they're on the outside, and these are also alternate exterior angles. So right here, let's write it in a color we haven't used before. Let's write it in black. These two are alternate exterior angles. And so are these, because they're on the outside. And these are alternate interior. And corresponding angles are a little bit different. They're these. I just want to kind of touch back on that part. Okay, so another interesting property, same side interior. So same side interior, well, obviously we're talking about these. So we're talking about interior angles. These are the four interior angles, but same side means they're on the same side of the transversal. So what we're saying is that C plus E has to be equal to 180 degrees. What's interesting about this is that it's also true for D and F right here because they are same side interior angles. And we can actually get this idea for the exterior angles and because that's also true. Same side exterior angles also add together to be 180 degrees. So those two are same side exterior. So they're on the same side of the transversal, and they are the exterior of the parallel lines. Those add up to be 180 as well. Now, we can see this a little bit better for the exterior ones if we were to collapse that interior. Watch what happens when we collapse the interior. I want to do this because it's really cool. I want to keep the line the same and have the transversal be the same. But look at that. It's the same line, and if we collapse the interior, like cut it out of there, you realize that you're really looking at, with the same side exterior, you're really looking at a linear pair, supplementary angles, and these two are as well. And the reason that that's cool and it applies and helps with this is because then we'd be able to use a linear pair right there to figure out what this is, and a linear pair right there to see what that is. But we don't need to prove that part. Euclid already went and did that for us. But the thing about same side interior angles is that these two right here add up to be 180. And then these two right here add up to be 180. And the ones I'm about to highlight in orange add up to be 180. And the ones that I'm showing in purple add up to be 180 because these are are same side interior angles. These at least. These are same side interior angles. These are same side exterior angles. And these are same side exterior angles. So just kind of, it'll take some practice and it'll take us using them. So let's use them a little bit. Let me just double check how long I've been recording. It doesn't tell me. That's cool. All right, let's just work on a couple of these, and then I'll switch videos, and I'll make a part 2. So in this case right here, We want to find the measure of A, so that's this. But what's cool about this is that we realize that we have two parallel lines and a transversal going between them, you know, like intersecting them both. That gives us corresponding angles. Corresponding angles correspond to, they're the angles made by the transversal and the corresponding parallel line. Two parallel lines, but these angles correspond to each other, so they are congruent. That means that must be 48 degrees. It's that easy once you'll start being able to visualize it really well. In fact, we can figure out all the rest of these as well. If we want to figure out this angle, then we can just do 180 minus 48, which is 132. And then this is also a corresponding angle. This is a vertical angle with this one, so it's 48 degrees. This is a vertical angle with that 132 catty-corner from it. We can use corresponding angles here to say that this is 48, or we can use the fact that these are same side interior angles. So many different things that we can do. But do you guys see how I have completely filled it out by having one angle? That's the amazing part about understanding these properties, because you can do this type of stuff in real life as well. You can set up two parallel planks of wood or metal, and then put something across it and figure out all of the information that you need to be able to build something else. And this could be like a slide for kids. Like this could be a part of a stand, this could be part of a stand, and this could be the slide, and you have to be careful with your angles to make sure that there's not a too fast of an angle of descent, because that's dangerous for kids at parks. We can use corresponding angles in this one. We can use a lot of different things. I want to use same side interior and say that these two add up together to be 180. 180 minus, so 48 plus B equals 180. Subtract 48 to get B is equal to 132. To be fair, we've already done that over here. It's the same thing. It's just finding the other side. But either way, 132. This is literally just finding this angle. It's the same thing. And we actually already did that, so I kind of spoiled it a little bit. But what's cool about that is these two are vertical angles. So you can do it a lot of different ways. You can take B, put it in here, and do that. But these two are vertical angles. So these two are vertical angles. But that also, you've got to realize that if those two are vertical angles, these are corresponding angles. So this is 48, which means this is 48. That's one way to do it. That's actually how the proof of, part of the proof of alternate interior angles goes. But using what we've just learned, we can also use the fact that these two are alternate interior angles. See how that they are both on the interior of the parallel lines, and they alternate which side of the transversal they're looking at, and which parallel line they're looking at. So those are alternate interior angles, so that means that they must be equivalent, congruent. All right, these are alternate exterior angles, so you can figure out that this is also 48. Because they alternate the side of the transversal and the parallel lines. So that's just one thing that we can do. Or you can prove it in a different way. You can say that this right here, this has to be 132. That this right here has to be 48 to make, because that's adds together to be 180. That this must be 132 as well, even though it doesn't look quite like that. They've changed the diagram on us. That's the issue. They've changed the diagram. This says 48. Those are alternate exterior angles. And see how the 48 was right here before? Again, I don't know if they goofed something when they were drawing this, but if it's wrong, it's because the diagram looks off. And obviously, it's not drawn to scale then. Same idea, though. Alternate interior angles. This is 132 by that logic, which means that this must be 48. So this is 48, unless they meant for this to be right there, then it kind of changes everything. So they might have used the same drawing, but they definitely tried to pull a Trixie doodle on us and switch the side that angle was talking about, because this one was on the inside, this one's on the outside. Watch out for that. Make sure you're not just using a protractor. So I'm going to quit the video for right now, just so I can make a part 2 for auxiliary lines and transversals that don't look like transversals until you start extending the lines. Stay tuned.